First calling out that number one, I am a mobile engineer who knows very little about machine learning. And that is part of the reason that this talk came to exist. For those of you that don't know, every year, Google puts on a little Android developer challenge. Last year was Jetpack Compose, and a couple of years ago, their challenge was for MLKit. And I was personally so overwhelmed by the really, really cool things that developers in the Android space were making that it was a huge like imposter syndrome moment for me. Like, how can all these developers, mobile developers, be so talented with machine learning? And so that kind of spurred me on to jump into MLKit myself. And so this presentation is a culmination of a couple of weekends of exploring MLKit. And so I hope that you enjoy it. So with that, let's go ahead and get started. If you would prefer to follow along on your own computer and not use my slide deck, know that these slides are available, as well as all the material that are in this presentation. If you go to bit.ly/WWCode-ML-kit, or this QR code will also take you there. I'll have that link again at the end as well. So first, let's starting off with some definitions of what is MLKit. MLKit brings Google's machine learning expertise to mobile developers in a powerful and easy to use package. So some important things about MLKit is first that it's optimized for mobile. MLKit's processing can happen on device, which means that it's really fast and it can unlock some real-time use cases like processing camera input directly. And it also works on an offline capacity, which means that it can be used for processing on device so that sensitive information in your pictures never have to leave your device at all, which is really important for a lot of users. Next, it's also built by Google. While when you look at Google's documentation on this, they say it's built by Google, which means that you're taking advantage of these really powerful machine learning algorithms that power Google's own experiences. But what I really take away from that is that it's already built. And so you don't have to be a machine learning expert to kind of get started and build ML into your mobile applications. And finally, that it is easy to use. And you all can tell me at the end of this talk whether you, in fact, agree with that. So next, awesome, we know what MLKit is, but what can it do? So the MLKit APIs are broken into two different categories. We have vision APIs, and we also have natural language APIs. So with our vision with our vision API, we have things like facial recognition, selfie segmentation if you want to build your own Snapchat replica, things like digital ink recognition so that you can write on your screen and be able to transfer that into actual text as well. Image labeling to pick out things in your images, position detection to decide how bodies are moving. And then on the natural language API side, we have language ID. And so we can actually use that to identify languages in images to let your users know what kind of language it's in. Entity extraction. So that is if you think about when you get text messages that say, hey, it looks like this message suggests a brunch date on Saturday from 10 to 11 with Sandy. You can add that into your own application using entity extraction from the natural language APIs. Smart reply, if you want to build your own LinkedIn replica with those interesting messages that it suggests you might send to a recruiter, and also on-device translation. And so this really does open the door for you to build some really cool and really powerful and really customized apps for your user base without having to build up these solutions from scratch by yourself. And next, who can use it? Something that I think is a really big advantage of MLKit is that everyone can use it, is that it's available for both Android and iOS, which is really cool because it means that it's available for consistent application experiences across different platforms. And so that means it's a really viable option to pull into production and put on both your Android and iOS app to build a robust solution for all of your users. And it turns out it's also available for Flutter projects as well. That was recently released. And so if you're building a hybrid cross-platform solution, you can also use some of the information in this presentation. Today, we're going to really focus on the Android side because I am an Android engineer. But know that a lot of this is really easy replicated on other platforms if you're developing for a different mobile platform instead. So with that, let's talk about our client for the next 30 minutes or so. We're going to meet our new client, Steve. This is our client, Steve, on his tractor. And some fun facts about Steve are, number one, that Steve is my dad. And this is Steve on his tractor. Something you need to know about Steve is that he plants a lot of things in his garden and cannot always figure out what everything is. My mom and dad are a dream team. My mom likes to buy the plants, and then my dad likes to plant the plants. And so he doesn't always know what he's actually planting. An exciting thing that happened in our lives is Steve that finally understands what I do for my job. He can tell his friends that I am, in fact, a mobile developer who builds applications for Android devices. And so, because of all these things, he has asked us to write an application to help him solve his plant dilemma to figure out what all the things in his yard are. Hi, Steve. And so with MLKit, I can say, yes, we can build this awesome application. And so today we're going to build a plant identifying app using the MLKit Vision Labeling API to help Steve identify his plants in real time. So let's get started. So before we actually jump into the code and start dealing with our machine learning APIs, let's get a little vocabulary and background in case you aren't familiar with the Android platform. We'll be writing a native Android app today using Kotlin, and all of our code will be inside one big activity. When we say native Android, this means that it's specifically written to run on the Android operating system. The Android operating system is an open source platform, and so Android, or a modified version of Android, is actually running in a lot of surprising places. Today we're going to be talking about Android phones, but things like your Kindle and sometimes refrigerators and things with any kind of smart screen are often also written on using a modified version of the Android operating system. Android is also a Kotlin first platform, platform for development. And so Kotlin is an object-oriented JVM language from JetBrains that should remind you a lot of Java, but it's more concise, less boilerplate as well. In 2019, Android officially did start becoming an Kotlin first platform for Android. And I, for one, could not be happier with that change from Java. A little fun fact about Kotlin is that it's named after Kotlin Island near St. Petersburg in Russia. And finally, all of our code is going to live inside this activity, and it will be called the main activity. If you're familiar with Java, you know that there's a special function in Java called the main function that kind of starts everything up. You can kind of think about our activity as kind of that main function for our Android application. It's what's going to call all of our functions and start running when you open your mobile application. And to just quickly get a feel for some of the UI elements that we're going to have on our application and the architecture that we're going to use. So we will be building a single activity application, just like I mentioned. And so that means there's going to be very little architecture at all besides organizing our code in that one document so that it's very easy for you to read when you go back and look at it. And the UI that we're going to build is we're going to use a constraint layout. And the constraint layout just kind of puts our UI elements relative to each other on the screen. And it's going to have an image view so that we can preview our image that we're going to run our ML on using our image labeling API. We'll have a recycler view, and a recycler view is just a list view element from Android that happens to recycle its views as you scroll through it, so that's a little bit more efficient. And finally, it'll have some buttons at the bottom to make it a really easy user experience for Steve. And with that, let's really dive in. Let's get into the MLKit part of this project. So how are we actually going to use it? First, we need to add those image labeling dependencies to our Gradle. Gradle is how Android is going to manage all the dependencies and libraries that we need to build and run our application. MLKit has two different options for how you can add that to your project. The first one in this slide is going to be an option that includes your machine learning model inside the application. And so that's shipped with the application itself. You also have an option, and that's this bottom option, that will pull that machine learning image labeler from the Google Play Store or Firebase when the app is opened or when it first tries to use it. This second way is going to save us a little bit of space, so our application will be a little bit smaller when you load it onto your phone. But the first one also has some added benefits that it's going to work out of the box with no network and can do everything offline. Since we are building this for Steve, and Steve and Kathy are notoriously frugal, and he's going to be out in his yard and you can't trust Steve and Wi-Fi, I'm going to go ahead and use this first one so that I have everything in my application. And so I'm just going to add that to my Gradle. We're also going to get started using the base model. Steve totally understands the value of building an MVP first. And so the first thing that we're going to use is the base model from Google. And so that's just going to be a model that has about 400 different labels that we can use out of the box without any extra work. And it's built to be a really general and varied list so that you can use it for pretty much any application and get back some meaningful labels, hopefully. And so this is a quick shortened list of some of the words you might find in that base model for the ML kit. Okay, and with that, we have our dependency in the app, we know which model we're going to use, and now we can start jumping in and coding. So step one is going to be preparing the input image. And so the first thing that we need to do is let Steve pick an image from his photos. Steve saves everything from our family chat and everything from Snapchat, so I know that he has a lot of images to pick from already on his phone. And so what we're going to do here is we're going to start an activity for result. And what activity for result does is it lets you leave the current application that you're in and go to a different application or a different activity within your application, and then return something to the original activity. So in this case, we're going to need to go out to your photos, pick a photo, and bring that back to the application. And so we set it up with a type of image and an action of getting that content. And we start activity for result. When you do the start activity for result, you'll also need an on activity result that responds when that data comes back. And so we also add in our override function of on activity result that pulls out the data from our intent. And so in this case, we are going to get back an image URI. And so we see that line, image URI equals data and getting the data out. And then we're going to call this function called setPreview, passing in that image URI that we got back from our activity for result. Once we have this image, we can start setting it up to pull it. We can start using that to get ready to call our image analyzer. And so what we have to do is take that URI and transform it into a bitmap. It turns out that there's actually several different types that we could transform this into that would also work with the image analyzer. But I picked bitmap for a couple of reasons. Number one, most folks within the mobile field know what a bitmap is, and it's something that we can kind of visualize and know what that object is. And then second, it actually ends up being the most efficient type for that image analyzer to run against. So it gives us performance enhancements as well. So what we have to do now is call this new function called getBitmap from URI. And all that's going to do is take this URI that we get from our content, from our data, and it uses this bitmap factory to go out and find the file and transform that into our bitmap image. Once we have that image, we're going to go ahead and set the preview for our application so that Steve is able to see that image inside his application as well. And so now that we have this bitmap created, we can go ahead and process that image. And this is where we're actually doing our ML kit stuff. So we see that we have a quick check to make sure our image bitmap is not null, and it shouldn't be because we just set it in the last step. And so the first thing that we now have to do is transform that image from a bitmap into this image input. And this image input is what the image analyzer actually needs to run the process function. And so we see this first line is input image.fromBitmap. That from bitmap could also be replaced with some of the other types that we could have used to create this input image. That from bitmap takes both the image bitmap that we've already created in the last step, and then the second argument of that function is going to be the rotation that we need. We're going to go ahead and assume that these pictures are up in the correct direction, and so we'll need no rotation, so we can pass in 0. Once we do that, we can go ahead and create our image labeler. And so this image labeler is using that base model to create its labeling object. And so now we have image labeling.get client, and that get client takes in a argument of image labeler options. I am again leaning on my MVP, and so I'm just going to go ahead and use the default options. But this options has things like if you wanted to set a confidence criteria and only get back labels that the image labeler thinks there's like at least 75% likely to be in your image. And so now that we have our input image and we have our image labeler, we can now pull these together to create our list of labels. And so on our next line, we have our labeler.process, and that's where we pass in our image input. This process is where the magic happens. And so what that process function is going to return is actually a task. And if you've done Android for a while, you might recognize the task as async task. And so it's actually really similar to the async task that we remember from networking back in the day. But this comes from the Firebase library. That task will return asynchronously a list of labels. And so to be able to respond when that list of labels come back, we're going to add an onSuccess listener for when the list of labels is successfully returned, and then also an onFailure listener for when that doesn't happen. And so in the onFailure listener, all we're going to do is throw up a toast in case it doesn't work for some reason. But in the case when we successfully get back a list of labels, then we can now use that to put our list of labels into our recycler view that we talked about earlier to display those on our screen so that you can easily see both his image and what is probably in his image as well. And so for this simple application, all we're doing is displaying that list of labels in our recycler views. And to do that, we just have to pass them into the adapter that bridges our main activity to that list view. Inside that adapter, we're going to bind each individual labels to a cell on our list. And so each image label that comes back in that list of image labels is going to have 3 different fields. It will have a text, which will be the name of the label from that original base model list. We'll also have a confidence that represents how confident MLKit is that label is in fact in your image, and an index. That index ends up being the same as a text. Those match 1-to-1 from the original base model. So if you look at the base model, you'll see both a number and a text. And so that will be the index and the text that come back on that image label. So those two things say really the same thing. And with that, we're going to bind the text to our list, as well as the confidence and the index as well. And with that, we're pretty much good to go. So let's go ahead and try it out. So we're going to go in, select our image. We'll pick a fantastic picture of Steve's yard, process the image, and within seconds, we see a list that includes things like forest, flower, jungle, plant, garden, which is pretty incredible. In a little bit less than 20 minutes, we went from 0 to an application that can identify a lot of things that are actually in that image. And not only that, but Steve would be so excited that Google thinks with some confidence that his backyard is in fact a jungle. So that was really cool, but where are we going to go from here? What we did here was use that base model because we were really building out that MVP, but what we really want to do is maybe make a custom data model to label the actual plants in Steve's yard. We picked one that labeled pretty generically some things that pretty accurately describe his backyard, like a garden, but we really want to build an application that we can look at a specific plant and say, this is a rose. And so let's take this a step further and look at making custom data models to label his plants. Before we jump into this, I want to quickly remind everyone what this talk is. I have a quick reminder that I'm a mobile developer and I can answer your most pressing questions about Android operating system. And I am not a machine learning expert. And so the things that we're going to talk about here are things that I thought were important from a mobile perspective about building these custom models, and not necessarily going super deep into TensorFlow. But I know there are a lot of great talks today on other aspects of machine learning that if you're interested in digging a little bit deeper into that side, I think that there are people here that can help you probably better than I am. It's also a helpful reminder that if you want to give a talk at some point, you don't have to be an expert to get up on a stage and talk about something really cool that you learned. And so with that caveat, let's go ahead and dive in. So how are we going to get started with custom models? From the docs on custom models with MLKit, it's going to tell you that there are 4 different ways to kind of create a custom model that you can pull into a mobile application. So let's talk a little bit about what the differences are between these different options. So the first is going to be TensorFlow Hub. TensorFlow Hub is kind of like GitHub, except for TensorFlow models. So you have creators who have gone out and created their own models and are sharing those publicly for other developers and creators to use. This isn't really going to work for us because we really want to build our own model this time. And so we're going to skip over this one. We can also use TensorFlow to convert it into the type of model that we're going to need for a mobile application. So for a mobile application, we actually need a TensorFlow Lite model because it's going in our tiny little operating system on our tiny little device. And so you can take a TensorFlow model that you already have and convert it into a TensorFlow Lite model. Unfortunately, I do not have a TensorFlow model, and so this probably isn't going to work for me either. We can also use AutoML, Vision Edge, which is one of the Google Cloud Platform options for you as well. And so for that kind of thing, you can load a bunch of images up, use AutoML to build out your model, and then host it on Google Cloud Platform and pull it into your application. I'm going to skip this one today as well, because Google Cloud Platform is its own beast that has a big learning curve as well. And so the final option is the TensorFlow Lite Model Maker. And with this one, you can use an existing model and retrain that model, which is called transfer learning. And that takes less time and requires less data than training a model from scratch. During training, an image classification model is fed images and their associated labels. And then each label is going to be a distinct concept or class that the model will learn to recognize using transfer learning. The model maker is going to support 2 different use cases, image classification and text classification. And since today we're going to be using that image identifier, this is a really great option for us. And today we're specifically going to look at this particular model maker, which is the Colab for image classification with TensorFlow Lite. And it's going to take us step-by-step through how building our own model. So what does this look like? If you use that link, which again, you can find the materials out via that link, bit.ly/WWCode MLKit, you'll find that this is going to open up a Jupyter notebook, which is going to guide you through the process of building your first custom TensorFlow Lite model. If you've never worked with Python or Jupyter Notebook before, that's totally fine. The really nice thing about this is it's going to manage a lot of the things that you have to worry about for Python by itself. And so it's just going to be able to line by line execute everything for you. The first step on this particular code lab is going to be just a couple of lines of code that you have to execute to kind of set up your environment. So the first line is going to pip install a bunch of important library required packages that you're going to need. If you're unfamiliar, pip is just the package manager for Python. And so some of the things that this is going to install are going to be things like TensorFlow, TensorFlow Lite support, TensorFlow.js, and a bunch of math packages to do this work for us behind the scenes. And then once those packages are available and installed in your environment, then we just have to import the ones that we need out of that. So once this happens, we can actually jump in and start using our images to use transfer learning to build our new model. It just so happens that Google actually has a very large data set of flower images that are publicly available. And so we are actually going to use that to get started building Steve's identification app. And so the first thing that we're going to do is grab all those images from Google Cloud Storage. So we didn't get out of using Google Cloud Storage and use this get file function to unzip and pull out all those images and put it inside our Jupyter notebook so that we have access in the following steps. And these kind of functions are going to come right from the TensorFlow core package. In our case, our flower folder, our folder of flowers is tarred, so we also have to extract that as well. If you use either the tar or a zip file, you'll have to extract those images out before it's able to get those images into the Jupyter notebook. And then using these 4 simple steps, we'll be able to create our model. So the first thing that we're going to do is, now that we have gotten our folder of flowers, we're going to now need to load that data into our data variable. So we use our image classifier data loader from the folder and load that data into our Python notebook. And so the output of that is going to tell us that this particular set of images has 3,670 images and 5 different labels. And our labels for this particular data set are going to be daisy, dandelion, roses, sunflowers, and tulips. Once we have that, we're going to break that data up further, and we're going to have a training set of data and a test set of data. And so 90% we'll use to train, and then the last 10% we'll use to test our accuracy of our model. And so after that, we're actually going to create. And so we have this image classifier .create, and we're going to put in that 90% of the data that we pulled from our folder. Once that particular line runs, then we will go ahead and evaluate our model, see how good it works. Since all of the data that we're passing in is already associated with the correct label, it can quickly decide how accurate it is using this evaluation function. And once we're happy with that, we can go ahead and export our model, and we're pretty much good to go. I want to take a tiny moment to talk a little bit about this single line that is the most important in this entire file, because this create function is the critical part of the library that is actually doing the transfer learning. And so in this particular line, we use transfer learning with a pre-trained model to create our new custom model. For transfer learning, we can use any kind of existing pre-trained model as a future detector. In the case of this particular example, I use the default pre-trained model, which is going to be called the Efficient Net Light 0 model. The reason that we use the Efficient Net Light model for our mobile application is that it's specifically a mobile-friendly image classification model. It's developed by Google and needs less computations and parameters to start classifying images. But there are some other ones out there, and you can definitely test them and see if one works better for your particular use case. There are actually 5 different efficient light models that we could use. So we're using 0, but there's also efficient light 1, 2, 3, and 4. And there are also some other ones that used to be used until this particular model was trained, including the Mobile Net Light V2 and ResNet 50. I tested mine with some of these other models. And so using the Efficient Net Light 0 actually worked the best for me. And I was at a 92% accuracy. Whereas if I switch to the Mobile Net V2 model training, I dropped down to 87%. And so with this create function, you have a lot of different options that you can play with. And I definitely recommend testing them out to kind of figure out what works best for the model that you're training. And so things like the different models is something you can pass in, as well as other things like changing the number of epochs, which can create better accuracy, because that's going to represent how many steps that it tries to take during a given run of the model. You can change the batch size to try to train it on more images at one time. You can also update the learning rate so that it responds to changes in the data quicker. I went ahead and found that using the base case for all of these works the best for mine, but that's probably also because both of these sets were trained by Google. And so now that I have that all that data worked out, I can add it to my model to my project by going into adding a new, and I find the TensorFlow Lite model at the bottom of adding it to my project. And that will open us up a wizard that we can then pull up the location from wherever we exported that model from, add our dependencies to our build Gradle. So we'll need new dependencies as well, and we can finish that up. After you do that step, you'll be able to look at your project and see what really changed. And so in this case, we see that we added new build features for ML model binding and also a couple new libraries that are going to make it more human readable and add support to our project for using a custom model. We can also look at the model and how the Android Studio is going to display that to us. And so in this case, we can see the output of our new model. And so we see that we have an input image that can be classified. We have an expected size, and it will be described using 3 different channels, red, blue, and green per pixel. And in the outputs, we have possibilities of 5 labels respectively. And so now we can actually use that model and trade out our previous default model for this new image model. It's going to end up looking really, really similar, which is good for us because we don't have to make too many changes. So instead of using that image input, we now need our tensor image, but we can still pull it from a bitmap. And so we have tensor image.fromBitmap, and that will create our new image that we need for our new model. And then we have to create our model as well. And so I imported mine as a flower model. And so I create a new instance of that. And then using that model and our TensorFlow image, we can now again call process, and it's going to return that list of probabilities. And then we can sort it by the descending it's by score. And so score is the same thing as confidence in the last model that we used. And as long as that's not empty, we'll do the same thing. We'll send it into our recycler view, set up our adapter, and be able to display those on our screen. And so again, we'll have that bind function and display both our label and our confidence using the label and the score from our new model. And so with that, let's try out our new model. And so if we look at this, we're now going to select an image. We'll use the sunflower image this time, and we see with a 96% confidence, we have a sunflower. And if we try that on our original backyard image, we'll select the same picture as last time, process that image, and we get all the different things at a much lower confidence, which is as well. So yay, now we can identify 5 different flowers: daisies, dandelions, roses, tulips, and sunflowers. But what happens if we want to add a new image? So this is an image of Steve's favorite flower. It's called a cannas. And so this is a huge part of his backyard. So let's look at how we want to customize this model to include this particular image. And so how we can see how we can scale up this model to everything in Steve's backyard. And it's pretty easy because we're machine learning experts right now already. And so we talked about how you needed to have this folder of these different distinct images with these distinct labels. And so if we look at the data that we are using to build this model, we'll see that we have this flower photos folder with daisies, and then 700 pictures of daisies, dandelions, and 700 pictures of dandelions, and so on. And so all we're going to have to do is add another folder, cannas, and add a bunch of pictures of cannas. And so we'll head out to the internet and get a bunch of images. A couple of things to know. It only supports JPEG or PNGs, and you'll need at least 32 images to build that model. So once I've done that, I can actually upload my own folder. So the last time I used one right from Google, but this time I will upload my new flower folders from my local copy, and then run through all those steps again and import it into my actual application. And with that, I'm going to use that same image to process using my new model. So I select that image, process, and we see cannas comes up with a 47.6%. You might wonder why that is so low in comparison to that 98% that we saw with the sunflowers. Since Steve isn't here, I'm going to, number one, throw him under the bus and say that he's not the best at taking photos. He really likes to zoom in instead of stepping closer. But also, I built this particular model with only 35 photos compared to the 3,000 that we started with of the other photos. And even only adding that 35 picture difference, I'm able to produce a model that can correctly identify that that is a cannas. For now, we've made this custom model. We could also use our camera so that he doesn't have to load an image every time he wants to do it. It turns out when we wanted to add a camera, it's actually a little complex because the Android lifecycle is a little complex all by itself. Here from a high level is how we're going to do that. We'll have to pull in some camera dependencies that specifically help us use the camera's lifecycle, and add a specific camera view. And so we'll also have to add a permission to our manifest to ask for permission. And then we'll add a little bit of code in our image to process that image. We'll have to use this process image provider and the image analysis classes to bind the camera to our activity, build an image analyzer that can convert the image proxy, which is what is going to constantly be coming through as we update our image from our camera, into that bitmap again, and then pass it into a process function a second time. I recognize that there's a lot happening in that sentence, and so this is actually completed out in those materials on the MLKit camera branch, if you want to take a closer look. And if we do this, we can check out one more time how that's going to work out. And so we can watch as we move around on different flowers. We see our camera, we see a daisy, and we see our list quickly updating as we look at these different images, which is awesome. So where do we go from here? We now know how to make a custom model. We now have the code for how to use the camera itself. If you check out the MLKit example from Google themselves, you can find an example that uses overlays the images instead of putting them on a list so that it can tell you which image it's looking at and labeling correctly. And since I am an Android engineer and love new things on Android, I would really like to rewrite this in the new UI framework, Jetpack Compose. And finally, last but not least, I need to convince my dad to use an Android phone so that he can use our awesome app that we just wrote for him. And so with that, as I wrap up, I just want to remind everyone that with great power comes great responsibility. We are using a machine learning model that we are not training, that we are transfer learning from something that is trained by someone else. And so it's always so important when doing ML work to be mindful of the bias that is baked into any learned model and the impact and potential harm that it can have on your users. And with that, I just want to thank you all so much for coming to this talk. Again, you can find this code out on my personal GitHub, Sierra O'Brien. It's in the folder examples called Kit Vision. And you can also find me online on Twitter _Sierra O'Brien, or a whole host of ways to get in touch with me at sierraobrien.dev. And finally, here's a picture of a happy Steve with his happy flowers in his happy backyard. And I'm open for any questions that you might have. Oh, I have to, oh, Sandy went away.
Here I am. Thank you so much, Sarah. That was a great presentation. That was awesome. So drop some questions in the Q&A. I know we have at least one. Let's see here. No, somebody would like to know if MLKit will work with Xamarin apps. Do you know?
That is a great question. And I do not know very much about Xamarin at all, to be very, very honest. So I am not sure. It does work with Flutter apps.
So Flutter, iOS, Android.
I assume with some of these other hybrids that do have actual Gradles and on the iOS side have whatever iOS has to process the plist, maybe, that I think you can probably pull it in. I think for a lot of the React Native and Xamarin type platforms, you can pull in dependencies, but I do not know the answer for sure.
All right.
So sorry about that. Let me know if you find the answer.
All right, we have another question. You showed 2 ways to include MLKit as a dependency in building your app. How does it work with different versions of MLKit?
I think many of them have 2 different options. Those options really decide whether or not you're going to ship the models that you use with the application or whether you pull those down. So with the second option, you can either configure it to pull it down when it installs. And so it will immediately pull it down when you install the application on your phone, or it can also pull it down the first time you use it. So if it's in a part of your app that isn't like a super popular feature for whatever reason, it might make more sense in that case to pull it down when someone needs it, versus if it's a key feature of your app, you might want to consider shipping it with the application so it's already there, or doing it when it's installing it for the first time.
All right. Are all the technologies here free? I know Google ML has its limits to the free tier.
Yes, so Colab is free. Everything here that I built today should be completely free with no limitations that I have ever run into.
All right. Does the model learn with the device/customer only, or can the model be shared/applied to all customers?
So this model is actually trained in that Colab, and so it's trained separately from however the user is going to interact with it. So you'll have to completely train your model before putting it into your application. It's not a model that's going to learn based on your user's interactions, for example. It's a model that is already trained to recognize images in objects in the images, image labeling. So it will be applied exactly the same across your consumer base once it's shipped with the application. It should perform about the same for everyone.
Okay, good to know. Is there some background in mobile development required to get started with MLKit?
I feel like that's a two-pronged question, is that MLKit is specifically for mobile. So MLKit, that phrase, is a library for a mobile application. However, we kind of went out and built that TensorFlow Lite model using Colab, and that has no dependency on ML by itself. It's actually just building you out a TensorFlow Lite model. I don't know if there are other use cases for TensorFlow Lite models beyond mobile. My assumption is probably, but my expertise is in mobile, so that's what I know about. But those are two separate things. So MLKit, yes, that's a mobile technology. Colab and building a TensorFlow Lite model, that's separate, and you can go in all kinds of directions and build all kinds of different models using that kind of technology.
All right, great, thank you. Well, it looks like we are just about at time, so I just want to take a minute to thank Sierra again. This presentation was great. We loved learning about Steve and this fantastic app that you've created for him. But thank you so much for sharing your knowledge with us.
Thank you all so much for hanging out. It was so much fun.
Yes, I hope everybody enjoys the rest of their day.
Bye.